Good day friends. Now today we are here to discuss about a problem based on relative velocity, that is kinematics. Now let's have a look. Now in the problem it has been given that there is a man who is standing on a road, right? And it's raining. Correct? It's raining. And he has an umbrella. He has an umbrella, right? And he just holds the umbrella by making an angle 60 degree from the vertical, right? So let's discuss it like this, right? This is an umbrella and the person finds that if he holds the umbrella by making an angle 60 degree from the vertical, this is vertical and he makes an angle 60 degree, correct, like this. So he is able to get away from the rain, right? This is the problem. Now after some time, what happens? He leaves the umbrella, correct? He leaves the umbrella and he starts running. He starts running with a velocity of 5 km/h on the same road, right? So now what you have to do is, you need to, at the time when he starts running with a velocity of 5 km/h, he observes that now the raindrops are falling vertically downward like this, okay, vertically downward, correct, when he starts moving with a velocity of 5 km/h, right? Now what do you have to find? Now you need to find out the velocity of the raindrops with respect to man and with respect to the road, correct? Now how to solve this problem? First of all, you need to understand that what has been given in the problem. The first sentence says there is a man who is standing on the road. Now on the road is stationary, right? That's an inertial frame. And then he has to hold the umbrella by making an angle 60 degree from the vertical, right? Means this is vertical and he makes angle 60 degree, right? Means he holds the umbrella by making an angle 60 degree from the vertical. So this angle is 60 degree, correct? Now look at the diagram here. There is a person in case 1. He is holding an umbrella in his hand. Now see, this is vertical, correct? This is vertical and the raindrops are in this direction. So that's why he holds the umbrella by making an angle 60 degree from the vertical like this, correct? This is the man, raindrops. This is case number 1. Now in case number 2, what happens? He leaves the umbrella and he starts running with a velocity of 5 km/h on the road, right? It has been given by the problem, right? So this 5 km/h is basically velocity of man with respect to road. This point is clear. And then he observes that the raindrops are falling vertically on his head, correct? And we need to find out the velocity of the raindrops with respect to man. Problem part 1 and part 2, velocity of the raindrops with respect to the road, correct? So now look at here. Let's make a vector presentation of the velocities given, correct? Now this, let's suppose this is an origin. Now this is the velocity of the man with respect to road, correct? And this is the velocity of raindrop with respect to man. Why? Because in case 2, the man starts running on the road with a velocity of 5 km/h horizontally like this, correct? And then he observes that the raindrops are falling vertically on his head like this. Look at the diagram very well, correct? So this is basically the velocity of raindrop with respect to man while running, correct? So this is the velocity of rain with respect to man. Now the resultant must be velocity of raindrop with respect to road. Now why it is supposed to be? Because in actual way, let's suppose if you are standing, right? So this is the actual direction of the raindrop, right? And the velocity. But in second case, this velocity of the raindrop and the direction vertically downward is the observed part. It is observed by the man while running on the road, right? So this is the absolute one, velocity of raindrop with respect to road. Why? Because the road is stationary. Road is not started running or moving, correct? So this is an inertial. Road is inertial frame of reference, correct? However, this one is the velocity of raindrop with respect to man, observed by man, of course. And this one is of course velocity of man with respect to road, correct? So now here let's assume that velocity of rain with respect to man is VR oblique n, right? This one. And the velocity of rain with respect to road, V raindrop VR oblique road, correct? Now once you are able to make this vector diagram, you can easily understand that this is a 90 degree because it has been given that this is a vertically downward, correct? This complete angle is 90 degree. This, correct, means angle AOC is 90 degree, and as this angle OBNC, this is 60 degree. It has been given by the problem, right? Because the person has to hold the umbrella by making an angle 60 degree from the vertical. Look at here, to protect himself from the rain, correct? So this angle is 60 degree, so this angle will automatically be 60 degree because this is a parallelogram, correct? This OA is parallel and equal to CB, and similarly OC is parallel and equal to AB, right? Right? Now let's apply tan 60 from this part. Tan 60 will be OC upon CB, right? What is OC? If this is your angle theta, tan 60 is equal to, this is perpendicular and this is base, right? So applying the formula, tan 60 is equal to perpendicular upon base, right? Now what is this perpendicular? This is VM oblique road, means velocity of man with respect to road. Velocity of man with respect to road divided by this. What is this? This is as parallel with this. So this is nothing but velocity of rain with respect to man. Velocity of rain with respect to man. Now again, which is equal to velocity of man with respect to road, it has been given as 5 divided by velocity of rain with respect to man. Tan 60, the value we already know. Since tan 60 is equal to root 3. So root 3 is equal to 5 upon V R oblique N. So from here we can find out the value. Velocity of rain with respect to man is equal to 5 upon root 3 km per hour. Correct? Now you can apply sin 60. If you apply sin 60, what will you get? See, the first part has been solved, that we need to find out the velocity of rain with respect to man. Velocity of raindrops with respect to man. And the second part, that you need to find out the velocity of raindrop with respect to road, right? This one, velocity of raindrop with respect to road, correct? So then again we can apply sin 60. Now applying sin 60, what will you get? You will get the same thing. Sin 60 is equal to, again, perpendicular upon hypotenuse, right? This is the perpendicular OC. OC means, what is this OC? Velocity of man with respect to road upon, this is the hypotenuse. This is what? Velocity of raindrop with respect to road, correct? Velocity of raindrop with respect to road, which is equal to sin 60. The value we already know from trigonometry, that is root 3 by 2, which is equal to velocity of man with respect to road has been given in the problem, 5 km per hour. Again, replacing the value, we will get velocity of raindrop with respect to road is equal to 10 divided by root 3 km per hour, right? Now I hope you must have understood this problem. This is a very important problem, right? And conceptual. The main part is it's a conceptual problem. If you are able to understand and if you are able to solve such sort of problems, your concepts of relative velocity, kinematics must be crystal clear, right? I hope you must have understood this. Still, if you have some doubt in understanding this, in understanding and applying the concept, so you can write a comment. I will be happy to resolve your all queries, right? So it's okay for today. Wait for the next video. Again, we will solve some very good problems that must be highly useful for your academics as well as your competitive examinations of engineering and medical. Till then, take care, bye bye, and thanks a lot for watching.